Course 1, Lesson 9 is called Number Line and Ordering and Comparing with the Number Line. Number line is a way to show numbers and how they relate to each other in order, and you're probably familiar with how they look, right? We have this number line right here, and straight line that includes our arrows like we've learned, and those at the ends show and remind us that those numbers continue both directions. Oftentimes 0, your origin's right in the middle. In this case, though, they kind of put it over to the left to show we're really focusing on these counting numbers over here. The counting numbers are 1, 2, 3, 4, 5. And the whole numbers add 0. 0, 1, 2, 3, 4, 5, and so on. Everything to the left are now part of our integers set because they include the negative numbers. Maybe not numbers you would use to count objects, but numbers like maybe a negative balance in a checkbook, or losing points in a game and having less than 0. Maybe that's a setting where you could have a negative number. These are good things to be familiar with, and a number line is good for showing it. Now, if you're asked, like in example 1, to order these 3-digit numbers from least to greatest, a couple ways we could do that. You're probably not going to draw a number line to show this to solve, but you might show it to prove that you're correct. A way to solve would maybe be to put them again in order that they gave them to you, but top to bottom, and then think in terms of place value. What 3 place values do we have filled with this number? We have the ones place, the tens place, and the hundreds. Okay, and we can look at all 3 places, and each one has a bigger number in each of the places, but which place is worth the most? Well, the hundreds place is worth the most because you're counting hundreds. So there's 2 hundreds here where there's only 1 in the other. So we know that's our biggest number. And then we look at our tens. Those are worth the next most, and this then is our next biggest. So the 121 comes second. And 112 is our smallest because the 2, it's bigger in the ones place, but it doesn't have that in the bigger places like hundreds and tens. So this is our least, and it said least to greatest, so we'll want to list them the way I think they show on the next page here. That's a way to solve these, is to think of it digit to digit, remembering what we know about place value. And then on a number line, they even prove, okay, this is what it would look like. We would have, our 112 and our 121 relatively close together, and then keeping in mind that difference between 121 and 211, that's quite a bit different. So we kind of like the number line to show how different 2 digits can be. When we compare 2 numbers, we decide whether the numbers are equal, and if they're not, we have signs for greater than and for less than. The equal sign says they're the same, and we read something like this: left to right, as 5 is greater than 3. We have the mouth always opening towards the bigger number because he's hungry. And since when we read it left to right, we're saying that this is greater than this, then we call this a greater than sign, and then less than sign. Eventually we'll learn greater or equal to, less than or equal to. And then of course there's the equal sign, but it doesn't have to just be numbers on each side. What if we made it a number sentence, right? 1 plus 1 equals 2. Simple enough. Can we do that with operations that have a little bit more to it, such as 16 divided by 8 divided by 2 compared to 16 divided by associative property, parentheses here, 8 divided by 2. So how do we figure? Will that make the answer different, or will they still be equal? Because obviously the numbers are all the same, even operations are all the same, but we have what's called the associative property where we group differently, which means we have to do this part first and then this part, as opposed to here we go purely left to right. So of course 16 divided by 8 divided by 2 is going to come to 1. Because 16 divided by 8 is 2, 2 divided by itself, any number will be 1. Here we do this first, which gives us 4, and 16 divided by 4, not a big number, but bigger than 1. So which way do I point it? They summarize this below here, and this is that answer. We want which sign is that, greater than or less than? That's a less than sign. Remember to follow the order of operations it says here on the reading math, right? Do the work within the parentheses because PEMDAS, P comes first, right? Can you use digits and symbols to write in numbers and symbols what they're saying in words? 1/4 is less than 1/2. Write your fractions implied. 1/4, 1/2. And they're reminding us that it's less than. Okay, just above here, they had a bigger number, not an operation they were comparing, and I want to make sure you feel comfortable with filling in the circle here. We have 5,012 compared to 5,102. How can we tell which one's bigger, or are they the same? Well, the digits come in a different order, while all numerals are the same if you shuffle them. This one puts a 1 here, and this one puts a 1 here. So it's a place value question. What's worth more, tens place? Or here we have a 1 in the hundreds place, because of course where there's zeros, that doesn't really affect the value. And hundreds are always bigger. So this symbol should be written like that. 5,102, the bigger number. Comparing, thinking about the number line too and how that would have looked. So you've got some lesson practice. Arrange the amounts here. Make sure you remember to do it least to greatest. Do it from least to greatest, right? And then comparing, let's do pick B or C, and then do F. So we're doing A, B, or C, and F. Thank you.